Hello and welcome into the examples video for lesson 11 for Precalculus 1. In this video, we're going to look at the various types of examples we have for our transformations of graphs, our function algebra, and our composite functions. Share the document camera with you guys here. All right, so for these first set of problems, we want to sketch by transformation. So instead of building a table, plotting points, excuse me, to draw these, we're going to use our parent functions and then our shifting, our reflecting, and so forth. So the first one, we have f of x is equal to x squared plus 2. So our parent function is what? X squared, it's the parabola. And so now we have to figure out, okay, which way is the transformation going here? So if you guys are in my class, if you have the solution process guide, it'll give you tips on this and hints. But from our content video, we know what? When our number is outside the function, this is our vertical shift. And it's as is, it's as we see it. So this means it's a vertical shift of +2 or up 2. So it's just a parabola that instead of having the vertex at the origin, excuse me, it's shifted up 2 units. And that's it. That's what that one would look like. Let's say we have g of x is equal to the square root of x plus 1. So our parent function is what? It's the square root function. But we have a plus 1 inside. So what does that do to this? Well, inside, if you remember that the little acronym IHOP is what? If the number's inside, it's horizontal shifts. It's the opposite of what I see. So because I see plus 1, I think of it as -1, or rather 1 unit left. So normally square root what? Looks like this. But it's going to take that and move it over 1 unit. So now it's starting over here and going this way like that. So that's what that graph would look like. And again, you can see it's so much faster, so much more efficient than, excuse me, than trying to make a table of values and figuring it out from there. Third one, a little more complicated, a little more involved. So I have 4 minus the absolute value of x minus 2. So what I would do is start listing these things out. So we have what? We have the absolute value function. And we work from the inside out. So because there's a -2 in here, think of that like +2. It's our horizontal shift. So it's right 2 units. And then as we move out, we have what? We have this negative sign here. Well, what does the negative sign in front mean? It reflects on the x-axis. And then lastly, this +4 is outside. So that's 4 units up. So it's what? It's this absolute value curve, which looks like a V, right 2 units. I should have wrote in there, right 2 units. So it's going to move it over 2 units. So now the V moved over this way. Then it reflects on the x-axis, so now it's pointing downward, and then it has to go up 4 units. So this point here is really 2 units over and 4 units up, and then it's the V shape pointing down, and I ran out of paper there, but you get the idea. So it's a V that shifted 2 units to the right, flipped upside down, and then slid up 4 units, which gives us that picture there. All right, the other thing you guys will be expected to do with regards to transformation is you'll be given the transformations and you have to write the equation that goes along with it. So for example, if your function is the cubic function, so x to the third power, but then shift it 3 units to the left. Okay, so again, give yourself some notes here. How do we know by looking at an equation that something gets shifted 3 units to the left? Well, that means I'm going to have a plus 3 inside. So it's going to say f of x is equal to x plus 3 all to the third power. So this is our cubic function, plus 3 inside because it's the opposite of what we see for our horizontal shift. So if it's going 3 units left, I need a plus 3 inside. What if I have f of x is the fourth root of x, and we want to reflect on the y-axis and go up 3 units. So how does each of these play out? Well, if I'm reflecting on the y-axis, it means I have a negative inside the function. So we saw up here, when we have the negative in front, that's reflect on x-axis. If I have a negative inside, that's reflect on y-axis. And then 3 units up, that's vertical shift. So that's going to be a plus 3 outside. So then I can do what? I have fourth root, negatives on the inside, so minus x, and then plus 3 on the outside. So that's how we would write the fourth root of x reflected on the y-axis and 3 units up. That's the equation that we would get. What if we have our function is x squared, and we want to shift up 5 units? So that's what? Shifted up, that's vertical shift, so that's going to be as we see it, so plus 5 on the outside. So therefore, it's just f of x is equal to x squared plus 5. That's the x squared function or graph shifted 5 units up. And then lastly, what if we have the x squared function shift right 4 units and reflect on the x-axis. All right, so right 4 units, that's horizontal shift, so that's going to be inside. And it's the opposite. So if I'm going right 4, that means I need a minus 4 inside. And if I'm reflecting on the x-axis, that's a negative outside. So I have what? I have the x squared function with a minus 4 inside. That tells me go right 4 units, but then it's reflected on the x-axis, so I need a minus sign in front. So that's what we would have for that guy. All right, so that's our transformations. What about our algebra of functions? So let's say we have the following. Let f of x equal 4 minus x, and g of x is equal to x squared minus 3x. So we want to find the following. First, f plus g of x. We want f minus g of x. We want f times g of x. And we want f divided by g of x. And all the domains of these combinations. So, first of all, if you remember for the algebra of functions, the domain is always going to be what? A intersect B. And then for the division one, this one also, G cannot be 0. So first, let's find the two domains. Well, for f of x, it's all real numbers. I don't have any roots. I don't have any even roots or denominators. G of x, same thing. It's all real numbers. So the intersection is going to be what? All real numbers. So for now, for the first one, f plus g, I'm just adding them together. Again, don't make this more difficult than it has to be. So it's f, which is 4 minus x, plus g, which is x squared minus 3x. So if I simplify this, I get x squared minus x minus 3x is minus 4x, and then plus 4. And again, the domain is all real numbers, or negative infinity to infinity if we have to put it in interval notation. F minus g. So again, it's just f, 4 minus x minus g, which is minus x squared minus 3x. So be careful with the signs. So when we distribute this, this is like minus x squared plus 3x. So we get minus x squared. This should be x squared up here. And then plus 3 minus 1 is plus 2x, and then plus 4. Three f times g of x. So that's f, 4 minus x, times g, x squared minus 3x. Oh, yeah, and again, the domain for this one, also negative infinity to infinity. So if I FOIL this, I get what? I get 4x squared minus 12x minus x to the third plus 3x squared. So I get negative x to the third plus 7x squared minus 12x. And again, the domain for this one is negative infinity to infinity. And lastly, and this is always going to be the trickiest one, is f divided by g of x. So it's f, which is 4 minus x, over x squared minus 3x. Nothing will cancel or simplify. So that's kind of it. So it's what? It's all real numbers, but g of x can't be 0, meaning x squared minus 3x cannot be 0. So if I factor out an x here, I get x times x minus 3 cannot be 0, which means x cannot be 0, x cannot be positive 3. So in interval notation, that would be what? Negative infinity to 0, skip 0, go to 3, skip 3, go to infinity. So that would be your domain for f divided by g. All right, and then our composite functions. And there's basically two types of problems you guys are going to have to know how to do. The first one, so let's use the same functions. So let f of x be 4 minus x, and g of x is equal to x squared minus 3x. First one, we want to find f of g of 1. Now, I could, and I stress could, I could find the composite function. I could take g, plug it into f, simplify, and then plug in 1. But instead, it's easier to do this in two ways. First, what is g of 1? So I use the g function. G of 1 is 1 squared minus 3 times 1, which is 1 minus 3, which is negative 2. And so really what I'm being asked here is what's f of g of 1, but g of 1 is negative 2. So really what's f of minus 2 is what this thing is asking. So now if I calculate that, f of minus 2 is 4 minus a negative 2, which is 4 plus 2, which is 6. So your answer there would be 6. What if we want to find g of f of 1? So first it was f of g of 1, now it's g of f of 1. So again, I'll work from the inside, figure out what's f of 1. Well, that's 4 minus 1, which is 3. So f of 1 is 3, so this is really asking me what is g of 3. So calculate that, plug it in, I get 3 squared minus 3 times 3, which is 9 minus 9, which is 0. So the answer for g of f of 1 is 0. All right, last but not least, so let f of x equal x over x plus 4. And g of x is equal to 7x minus 4. So first we want to find f of g of x and its domain. So f of g of x means f of, well, what is g of x? It's 7x minus 4. So plug that into f anywhere we have an x, so we get what? 7x minus 4 over 7x minus 4 plus 4. So now simplify this, we get 7x minus 4 in the top. The 4's cancel out, so just 7x in the denominator. Can I cancel the 7x's? No, I may not. Don't cancel your 2's. Don't cancel your 7x's. If I can't cancel 7x everywhere, that's it. That's the best I can do. But now I need the domain. And remember, domain with composite functions is a little tricky because first, I need the domain of what I just found, f of g of x, which is what? The domain of this guy. So the only thing I have to worry about is 7x cannot be 0 or x cannot be 0. But then I have to intersect this with what? Well, whatever the domain of the inside was. So the domain of g of x. Well, what was the domain of g of x? Well, this is the domain of g of x is, again, all real numbers. I don't have an even root. I don't have a denominator. So there's nothing to worry about. So therefore, the domain of this guy in interval notation is negative infinity to 0 union 0 to positive infinity. So that's the two parts you would have to know for that. And then number two, what if I want to find g of f of x and its domain? So that means g of f, well, f is what? X over x plus 4. So plug that into g. So I get 7 times x over x plus 4 minus 4, which is 7x over x plus 4 minus 4, or 4 over 1. And simplify this. So we get what? 7x minus 4 times x plus 4, all divided by x plus 4. So this is minus 4x minus 16. So 7x minus 4x is 3x minus 16 all over x plus 4. Whoops, I'm so sorry. I skipped that whole thing. Sorry. So g of x over x plus 4 is equal to 7x, which now is 7 times x plus over x plus 4 minus 4. So just distribute the 7, so you have 7x over x plus 4 minus 4, or 4 over 1. So cross multiply, 7 times x is 7x minus 4 times x plus 4. So if I distribute this minus 4, I get minus 4x and minus 16. And then simplify, 7x minus 4x is 3x, and then minus 16 all over x plus 4. So the domain, first of all, for this guy, so the domain of the composite, g of f of x, is what? X plus 4 cannot be 0, so x cannot be negative 4. And then also intersected with what? Domain of the inside function, so the domain of f of x. So if I go back up here and look, domain of f of x is what? X plus 4 cannot be 0, so x cannot be negative 4. So it's x cannot be negative 4 in both cases, which would be what? Negative infinity to negative 4 union negative 4 to infinity. And then the last thing I want to just show you how to do, let's say we have g of x. It's like, wait a minute, g of g. Well, just do what it's asking you, right? It's g of the g function. So g of 7x minus 4. So plug that in anywhere you have an x. So you get what? 7 times 7x minus 4 minus 4, which is 49x minus 28 minus 4. So 49x minus 32. So if you have f of x, you're just plugging f back into itself. If you have g of g, you're just plugging g back into itself. That's it. Don't overcomplicate it. So that's it. That should give you an idea how to do all the different types of problems you'll be expected to know for the mastery sets, the in-class assignments, the exams. And so come on back and we will look at lesson number 12.